So now we're going to take a look at the cranking system control circuits, the basic wiring of how these are set up. So when we're, again, troubleshooting, having a schematic to go through and figure out how this is set up, what's in the circuit that could prevent it from starting, and doing some simple checks on the starting circuit itself. So again, depending on what system you have and how the wiring schematic is set up, being able to trace through and figure out if there is a neutral safety switch, if there is a clutch switch, if the PTO is engaged, it may not allow the starter to start. So all of these things you're going to pick up from your schematics. So again, all of these will be in series to allow our start relay to engage our solenoid. So go through, take a look at the PowerPoint and see how each one of these set up. The other thing that a lot of people don't take a look at is it's a thermal switch. Now a thermal switch is a bimetal strip. If it gets too hot, the contacts will open. Easy, how do we check it? We just basically take a meter inside there and see if we've got continuity. If we have no continuity, that means that the switch has got too hot and the bimetal strip is open and can't close again. Now once these cool down, these should close, but if it doesn't, and we still need to start the vehicle, what we can do is take the plug out, don't cut the plug and tape the wires together, just put 2 wires in there and tape it all up so you have continuity until you can get a new one. And usually these are in the end. So when we take a look at the start solenoid itself, the basic function of all start solenoids is identical. They just may look different depending on the starter motor that we have. So what happens inside? Well, when we energize the S terminal, which is a solenoid terminal, we have 2 sets of internal windings. We have a pull-in winding and a hold-in winding. Now the pull-in winding is a heavier wire, so when we run power through it, it creates a larger magnetic field. Once this is pulled in and this is engaged into the flywheel, our pull-in winding is going to drop out. Our hold-in winding is going to hold that solenoid in place until such time as we disconnect the power. Once that drops out, the spring will push this back, which will then disengage our start drive. So this is how our wiring is set up, okay? So this is, again, we have a movable iron core in here, and how it normally sits is out here, like this. And as soon as we energize this, the flux lines want to contract as much as possible, and that's what's going to drive this into this position like this. And again, you can take a look at the 2 different sizes of wires. So here's our pull-in winding, and this is our hold-in winding. Now what happens is, as power comes in here, when we energize our key switch, both of these get energized at the same time. But as soon as this button contacts here, our pull-in winding drops out. Because what we'll end up with is power on both sides. I've got a little demo to show you later. So without this engaged, power can come through here, through our start motor, through our brushes, through our armature, back out our brushes. So this is how our circuit's set up. So how our pull-in windings and our hold-in windings are set up. Our pull-in winding gets its ground through the whole start motor. So it will go out our M terminal, out into our motor through our positive brushes, through our armature, out through our negative to ground. But once we contact these 2 points, it doesn't get a ground. We have 12 volts on either side. It has to drop out. But our hold-in winding on our start solenoid, it gets its ground from the G terminal on the front cover. So it will always have its own ground. So this is, again, taking a look at different sizes of wire. So when we have a larger diameter wire, we have lower resistance, which is going to make a stronger magnetic field. So when we energize this, we're going to get, let's just say, 30 amp draw. On our other one, we're going to get 12 amp draw. So when our start solenoid pulls in, it takes more power to pull it in than it does to hold it in. So now we can use this extra power for running the starter motor. Now again, if you take a look at how this drawing is set up, is on our S terminal, and this is the one that comes from our start relay. Again, both our hold-in and our pull-in windings are energized through the S terminal. Our hold-in winding gets its ground through the G terminal, it goes to the starter. But our pull-in winding gets its ground through the motor. So once this gets engaged, I have 12 volts that runs through here, but I also have 12 volts here. This can't stay engaged anymore, it has to drop out. But our holding winding still gets it from the ground terminal, so it will always stay engaged. Again, taking a look at our start relay. Now a relay, all it's doing is we're using a small amount of power to control the large amount of power to send it down to the solenoid. So we have our movable iron core in the middle, and when we energize this, as long as we have a ground, it's going to pull this up. Again, it wants to get its magnetic flux lines as small as possible, pulls this up. This copper plate will make contact with this and send power out to my S terminal on my start motor. Now we see these relays in all different types of configurations, and one of the things that we have to pay attention to is how we mount these. Now we want to mount these like this, so that it's down like this. If we mount it the other way, this is a very light spring that's in here. And what happens is, bouncing down the road, this can make contact with these. And with that, it's going to short out and try and start it. So always mount it in this position like this. Now we're going to see a couple different types of relays. We might see one with two big studs like this, with only a single stud, which means that this will be internally grounded. If it has two studs, then we have to ground it. There's no internal ground on it. So again, they come in all different sizes. So if you take a look at this one here, it's only got a single small stud. So it is internally grounded to this case here. And again, this has to be, if you're going to mount this on anything other than metal, you have to then run another ground wire to something that's got a good ground. Again, coating these with a protective cover to stop any corrosion is a great idea. And again, when we take a look at our series parallel switch and how they work, understanding if you ever have to wire one up, make sure you wire it correctly. And that's it for the power circuits.